So vertex form, we're gonna graph this quadratic. You want a calculator, and so we'll do 2 videos. Okay, so look, what's my A value? Well, remember, it's A, H, K, and I tell you guys, you go opposite H, can you see? Yeah, you follow K, so opposite of what your eyes see. Okay, so what's my A value? Huh, 0.5? Okay, is that number positive or negative?
Positive.
Positive. Okay, does that mean it's concave up or concave down? Up. So it's going to be up, and then this is going to be my vertex, right? So it's up. Okay, we're going to skip max min, axes, max min value, because let's first get to vertex, okay? So you guys can see how it gets repetitive. Okay, what's my H value? 3, and what's the K?
7.
7. So my vertex is 3, 7, correct?
Wait, is it not negative 3?
No, you go opposite H, follow K, because if it's X minus 3, it's X minus, and then the H value is 3. That's why you go opposite.
That confuses me. I don't like...
It's the form. It's substitution. Okay, so now you have, okay, max min point, max min value. Okay, because the parabola is concave up, this vertex is your lowest point, right? And so that means whenever it's concave up, you have a min point and a min value. You'll see with concave down here, it'll be max. Okay, now what's the max min point? This point is always your vertex point. So this is 3, 7. Okay, what's my max min value? It's going to be the K value, or it's from the vertex, it's this number here. It's the Y value of the vertex. So that is just 7. Okay, so now let's go to the table, and then I'll stop the video, and then we'll do it again, because otherwise it's going to be real. Well, we'll see how long it is. We're going kind of fast. All right, so look, if I move to my table, my vertex is 3, 7, so you put it in the 3rd slot, and now we're going to go up, up, down, down. Okay, what do you guys want? 1, 2, 3, 4, 5, or 5? 1, okay. And remember, it's just your number line. If your number line is at 3, go 1 to the right, 1 to the left. That's 2, 4. I was like, I don't even know. 1, 5. Right. Okay. And then all you do is just turn it, and that's your table. Okay. All right. Input, output. You need to take your x values and substitute it into the original function that's given to you to get the output values. Otherwise, you can't graph anything. All right, so you get a calculator. You can load it all in, but I'll do it by hand in a second. And I'm going to substitute 1. So 1 minus 3 squared. Do not forget about the squared. A lot of you guys do on a quiz or a test. Plus 7, and I get 9. Right? And if I solve it by hand, right, 0.5, 1 minus 3 squared plus 7. If you know order of operations, this is -2. -2 squared is 4. Don't you dare multiply the 0.5 into any of these until you square. Okay? Plus 7. This is 2 plus 7. There's my 9. Right? So calculator or step by step, it should be the same. Okay. 2. So now let's substitute 2. And if you don't clear the calculator, I get 7.5. Yeah? Bless you.
Bless you.
Okay, and so now we're going to go ahead and plot it. The video's not too long, huh? We could keep going. Okay, and so 1, 9. So this is 5, 9. 2, 7.5. And because the a value is 0.5, it's a fraction, it's more bowl-like. See how it's like, it's not as 2b like the 5x squared or the 3x squared that you had. Because it's a decimal, it grows at a slower rate than the 5x squared or the 3x squared, so it's more bowl-like. It widens. It's not as narrow or 2b. Okay, so now let's talk about the ones that we skipped. Let's see if I can get everything on the screen. All right, look. Axes of symmetry. Okay, your axes of symmetry, I'll write it here. Okay, it is a vertical dashed line. It's always the h value. So x equal h, or it's the x value. So in this case, it's 3. And it's a dashed line that cuts through your parabola at the vertex, because it's that fold that if I was to fold it, they're equally mirrored of each other. So this is called axes of symmetry. Or they call it sometimes the line of symmetry, or just AOS. And so that's x equal 3 right there. And that's what that is. Okay, max min point. Remember, that's your vertex. So that's why here's my vertex, right? Which is here in the table. It's the third right point in the table. And then it's also my minimum point, right? And in this case, it's a minimum because it's concave up. Yeah? Okay, now what's the minimum value? We'll eventually start talking about domain and range, but baby steps, okay? The 7, which is the minimum value, which is your k, that'll make more sense when we start talking about domain and range, that if you look at your y-axis, see how if my vertex is here and I make a horizontal line, see how the parabola is existing above the pen, but there's no points below the pen? That's what domain and range are. It's that restriction of where does it exist on your coordinate axes, your plane. Where does it exist? Domain is x, range is y, so that would be a restriction on the range. Range. I said weird. Okay. We'll work to that. We're not doing that right away. Okay, so you're going to get a lot of these where it's just very systematic. And honestly, it's not bad. You guys do really, really well with it. Okay, how do you mess up? If you forget to do your opposite h and you did -3. Okay, so say I plugged a -3 in. If you're taking a quiz with your partner and you do not switch the h, and so you're now -1, -2, -3, -4, -5, right? All of a sudden, you have huge numbers. And so that's where you guys have to realize, so now if I plugged in a -1, I'm at 15, and so your numbers are larger, and you're like, okay, I know Miss Kenny's not giving me this, because obviously I'm giving you this little coordinate plane, so we try and keep the numbers there, okay? So if you're gonna mess up, it's a negative error. And so that's why you and your partner have to pay attention so you guys can fix each other, because this is really, really common. Like even in my im2 classes, their tests, I have kids that left the negative and didn't go opposite h, follow k. Okay. Oh, I forgot to do this. Horizontal shift, vertical shift. Okay, on your parent functions, your parent parabolas that you guys had in your packets. Oh, it's over there. Remember how the parent ones, they're at, oh, here, we'll use this, but we'll cross this out. Say y equal x squared or 5x squared. See how the first ones were at 0, 0? There. Okay, so in regards to this, compared to this one, my vertex is at 3, 7. So horizontally, how do I go from 0, 0? How many units do I move it to the right? 3. So I go right 3. Or you can even just arrow 3. And then how many units up or down?
7.
Up 7. So, and again, you guys do great with this. So if it's positive, it's right. If this was negative, it'd go left. The y value, it's up or down. If it was a -7, I would go down 7, but it's up 7. And so from here, to shift that vertex, I'd go right 3, up 7, and that's my point. I think we covered everything. Yeah, and that's it. Okay, you guys will try the second one. I'll give you what the vertex is. It should be -1, -9, right? Yeah. Okay, and then we'll verify it tomorrow because I don't know what time it is.
God, okay, you were right this one
And
time.
then we cut the video off. Oh, 26. Oh, we said like 16 minutes. Yeah. 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 Just take a pass so you know get one.